Okay, this is the last video of the unit, and it's graphing the inverses. Inverse sine, inverse cos, and inverse tan. All your pictures are done for you. Just follow along with me so you can see what I'm doing here. Right now, we've talked a little bit about inverses, but why doesn't this sine graph I have here, the picture I have below, why doesn't it have an inverse? Hopefully, I'm hoping you remember back. Remember we had something called the horizontal line test? Well, that's failing the horizontal line test. And when it fails the horizontal line test, it does not have an inverse. So it fails the horizontal line test. It's not one-to-one. Alright, so we're not just done. We can't just say it doesn't have an inverse and be done with it. What we do instead is we only look at part of the graph. And the part of the graph that we look at is going to be this piece I'm putting in black right here. So from that bottom lowest point to this upper point. I can look at just that black piece because if I draw a horizontal line anywhere within that black area, it will only hit at one point within that black area. Okay, so what I did is it's called restricting the domain. Okay, and it says, so we had to restrict the domain. So what do we have to do in order to be able to graph the inverse? Your answer there is restrict the domain. Mean only look at a piece of the graph. And it's asking, what is the restricted domain? What did you have to restrict it to? Well, domain are your x values. I had to restrict it from here to here. Those here points are exactly negative pi over 2, pi over 2. So the restricted domain, I used a bracket to say include it, is negative pi over 2 to positive pi over 2. That's a very important question for the Regents exam. It's normally a multiple choice. It's going to say what is the domain of the sine x in order for the inverse sine to exist. And you look for the answer that says negative pi over 2 to pi over 2. Now this picture that I have below, this one right here, is the same as this picture except only the black piece is drawn in. So if you imagine me just drawing that black piece and expanding it a little bit, it would be this picture right here. Some important points we look at to help us find the inverse will be these 3 points in red. So for a sine x graph, I can see I have the points, and this first point is at negative pi over 2, negative 1. I can also see I have the point 0, 0. And the last point is at pi over 2, positive 1. If you remember about inverses, you have to switch the x and the y. So instead of graphing the point negative pi over 2, negative 1, I'm going to graph the point negative 1, negative pi over 2. 0, 0 remains. And I'm also going to graph the point 1, pi over 2. If I look at this graph below, that's exactly what I did. Negative 1, negative pi over 2 is right here. 0, 0 is in the middle. And 1 pi over 2 is right there. So based on those 3 points, I was able to draw my new inverse graph. And this last piece just shows the sine graph and its inverse graphed together. Okay, so that's your inverse sine graph in general. Again, the most important piece is that you know that restricted domain. Cosine graph, again, right now it fails the horizontal line test. So what I have to do is restrict the domain. I only look at a piece of it. And the piece I'm going to look at is what I have in blue, from highest point to lowest point. That piece in blue goes from an x value of 0 to an x value of pi. So the restricted domain is from 0 to pi. What I did in this picture right here is the just 0 to pi piece graphed. Let's look at some important points here so we can see how to graph the inverse afterwards. So important pieces that I see the point 0, 1. I see this middle point right here, which I know it's hard for you to see your labels, but that point is at 0, pi over 2. And this last point down at the bottom is at pi 3.14. Yeah, pi and then -1. So that's my cosine x graph. To get the inverse, you flip the points. So we graph the point 1, 0, pi over 2, 0, and -1 pi. If I look at my picture on the left-hand side here, that's exactly what I did. Okay, I graphed the point 1, 0, which is right here. Pi over 2, oops. Sorry, I made a little mistake. Back up here for a second. This isn't the point 0 pi over 2. I was looking ahead. That's the point pi over 2, 0. So this point flipped is 0 pi over 2. Sorry about that. I just read the point wrong. So now looking at my graph, I can see I graphed 0 pi over 2 right here. And I also graphed -1 pi up here. So you can see the cosine graph and its inverse. With them graphed together, you can see the picture on it's your bottom, but my right-hand side. Again, most important piece is that restricted domain from 0 to pi. The last one we're looking at is tangent. Okay, that's our normal tangent graph. We saw that yesterday. Right now, it's failing the horizontal line test. So we restrict the domain. We're only going to look at the piece that I have in black here. That piece I have in black goes from a distance of -pi over 2 to pi over 2. Remember yesterday we had those asymptotes? It wasn't allowed to touch that piece. So instead of my restricted domain including those values, I'm going to use a parenthesis instead, or a rounded bracket, as opposed to a square bracket. So to say I go from -pi over 2 to pi over 2, but don't include those values. If I look at this graph as kind of zoomed in a little bit, it'll look like this picture. This picture flipped will end up looking like this when you switch your x and your y values. Notice as I am approaching pi over 2, it's going up forever. So what's going to happen instead is as I approach pi over 2 on the y-axis, it's going to go right forever. And now as I approach -pi over 2, it's going down. So when I approach -pi over 2 on the y-axis, it's going left forever instead. At this point, for your do now, please answer the questions that obviously did not come out well on my picture. But you have 4 do now questions to try. Go back to the notes we just did to help you out with them. And then we're going to work on something else in class tomorrow.